Hello and welcome to the revision session for organic chemistry grade 12. So the first part, which is part 1, is going to be looking at multiple choice questions. So the first question to look at is which one of the following compounds below is an aldehyde? So what we are going to do, since the revision session, we're going to draw the structures of these compounds from A to D, and then we analyze each and one of those organic compounds. So I'm going to use condensed structural formulae. So the first one, as we can clearly see, we have the CH3 group, and then we have the CO group attached to hydrogen. And then for B, we have the CH3 group attached to the CO group, which is also attached to another CH3 group, which we refer to as the R group. All right, and then C, we also have the CH3 group, which is attached to a CO group, and then we have an OH group of atoms, which is also part of the molecule. And then finally D, we have the CH3 group, which we can also call the methyl group for simplicity reasons. So we have the CH3 group, and then which is attached to the OH group. So further discuss. So all of these organic compounds, they have functional groups which are contained in them. So the first three organic compounds, you'd note that there is this one common functional group, which is the CO group, that you find in all the first three organic compounds. So the CO group, which is namely or known as the carbonyl group. So now the carbonyl group, it is one of the functional groups of organic compounds, and we're going to discuss again since we all have the carbonyl group. Now we know that if it is an aldehyde, it must have a formyl group, but the formyl group, of course, contains a carbonyl group. Right, so we'll analyze each and every compound, and then we are going to discuss why this one does not belong to a certain group. And then now, when you consider the first compound, then we look at the third and the fourth compound again, which is C and D. They all contain the hydroxyl group, which is the OH group, which is also known as the functional group of alcohols, right? So now we consider now the first organic compound. It has that formyl group. So when a carbonyl group is attached to at least one hydrogen atom, then we say the group is a formyl group. So formyl group, where do we find formyl groups as the functional groups? It's only in aldehydes at this particular stage in grade 12. So aldehydes contain the formyl group as their functional group. And then only ketones will have the carbonyl group as their functional group. So if you consider B, only a ketone is there. And then C, you have a carbonyl group and a hydroxyl group. When you add the two, then they give us the carboxyl group, which is a combination of two functional groups. So carboxyl groups, we know that those are functional groups for carboxylic acids. So if you have a carboxyl group, then you know that's a carboxylic acid. And then finally, you have the D, which is alcohol. I have already mentioned that. So with D, the only functional group that we have there is the OH group, which is the hydroxyl group, which is the functional group of alcohols. So as a result, then going back to our options, the correct answer will be A, which is, to be more specific about the name, that's methanol. And then 1.2, as we move forward, says the a reaction represented by the equation below takes place in the presence of a catalyst, right? So these are reactions. So if you can clearly see there, the reaction is between nothing else. We only have that organic compound, which is a larger molecule, which is going to be broken down into smaller and more useful molecules. So we know that as thermocracking. So thermocracking is the breaking down of larger molecules into smaller and more useful, or cracking in other words, because we have the one that we need to know about it is the thermocracking. So as a result of that, then we consider the options that we have there. You can clearly see that's thermocracking, or that's cracking in other words. So the option that we have, which would be the correct answer, will be B, considering the nature of our reaction. And of course, other reactions will be discussed later. Addition, substitution, and polymerization is no longer part of your syllabus. And then we consider 1.3, the structural formula of the organic compound below. As we can clearly see, we have the first carbon atom attached to 3 hydrogen atoms, and then the second is attached to a certain group. So the first thing that we need to do, the question is asking which one of the following is the correct IUPAC naming for the compound. So the first thing, we identify the longest continuous carbon chain starting from the left to the right. We can clearly see there we have our longest carbon chain. We're also allowed to start from right to left, right? There we see. So the longest continuous carbon chain in this case is 5 carbon atoms. But then, which direction are we supposed to start from? From the left or from the right? But what is it that we consider? We would have, of course, to consider the quickest way we can quickly arrive on the what you call this, on the functional group, since we now have a functional group. So if there was no functional group, we would only have considered the branches. But before we do that, then after identifying the longest chain, then we identify our branches. So we have the methyl branch at carbon atom number 2 or 4. We'll see about that. And then another methyl branch at carbon atom number 4 or 2. So we have 3 methyl groups. And then now their positions obviously will be determined by the longest continual carbon chain where we are going to start. So in this case, considering the fact that if we start from left and then quickest is number 2, and then we start from right, and then we arrive at our functional group at carbon atom number 3. So it's better we start from left going to the right. And then therefore that means the first branch is at carbon atom number 2, and then the other 2 branches there at carbon atom number 4. So having 3 branches of the same type, then that's we call that a propyl, right? That's number 1. I mean, that's tri, sorry. So we have trimethyl. And then considering our options, then the first one is out because now it is starting from right to left. The second one is also out for 2 reasons, starting from right to left. And then we also have the branch being, the functional group being at carbon atom number 3, yet the one that we are considering is carbon atom number 2. And then C, which is the correct answer, then we can clearly see 2.2.4 trimethyl pent 2 in. And then the last one, which is D, is also out because it is looking at the functional group being at carbon atom number 3 instead of 2. So the correct answer there will be C. So then let's move on again. We consider 1.4. 1.4 says which one of the following statement is correct? Alkenes. So there are so many things that we know about alkenes. Some of them are true, some of them are not true in this statement. So in the first one, say if the general formula is CnH2n plus 2, that's not correct. We only know that those are alkenes with that general formula. Unsaturated, yes. We know alkenes and alkynes, they are unsaturated because of the fact that alkenes, they have a double bond, and then alkynes, they have a triple bond. So as a result of that, we classify them as unsaturated. And then let me just write one next to the other instead of the full name. Right, so we have alkenes, which is C, double bond C, and then alkynes we have C triple bond C. So because of the triple bond and double bond, or because of multiple bonds between carbon atoms, then they are said to be unsaturated. And then we have C, which readily undergoes substitution. The addition is the favorable reaction for alkenes, not substitution. And then have a triple bond between carbon atoms. Those are alkynes. So then the correct answer, the one that is there, is B, which fits exactly into alkenes. In as much as it doesn't apply only to alkenes, it also applies to alkynes. And then 1.5 reads, the following equation represents the cracking of a hydrocarbon at high temperature and pressure. So now let's rewrite this equation, because there's something that needs to be done at the end. So which one of the following is the IUPAC name of compound Y, the one that we are not given? So the first thing that we need to do is to consider the chemical formula of compound Y through balancing. So there is the equation. We have C11H24 to give us 2. We have to consider that we have 2 ethene compounds, which contain 2 carbon atoms and 4 hydrogen atoms. We have Y, which is unknown to us at the moment. And then finally, we have C4H10, which could possibly be butane or methylpropane, right? And then now we need to balance out and find out what could possibly be Y. So the first thing is we do that through balancing the number of carbon atoms. So on the left hand side, that's where we have the most at the carbon atoms, which is 11, and then on the right hand side we have 8, which is 2 times 2, which is 4, plus 4, that's 8. Hydrogen atoms on the left side, we have 24. I made a mistake in the beginning. Then we also have on the right side of the equation with 18, which is 2 times 4, that's 8, plus 10, that's 18. So now, how many carbon atoms are left from to balance out the ones that we have on the left hand side? We have 3, and then how many hydrogen atoms? We have 6. So the chemical formula of our compound is HC3H6. So C3H6 can only be an alkene because it obeys the general formula of alkenes. So then, considering our options there that we have, so we know B and D, they're not correct answers. B and D, those are alkenes, so they're automatically out, right? And then our alkene must have how many carbon atoms? 3. So the only one with 3 carbon atoms between A and C, it's A, which is prop 1 in. So that will be our correct answer for 1.5. And then we'll move on to 1.6. So when 2-chloroputane is strongly heated in the presence of concentrated sodium hydroxide, the major product formed is. Now, so the first thing that we need to do, we draw the structural formula of 2-chloroputane. And this is a reaction. The 2-chloroputane, it is an haloalkane. And we know that haloalkanes, they usually undergo about 3 different types of reactions that we learn in grade 12. So we have 2 substitution reactions, and then we have 1 elimination reaction. So it is based on the conditions that we usually have for our reactions. So 2 substitution reactions. We also have a strong concentrated base, but then in the presence of water, and then another reaction takes place. Another substitution reaction, that's when we have the base being diluted. Now, in this case, let's consider the information that we have strong heat, right? So there's heating, and then we have concentrated sodium hydroxide, and then the product must be a major product. So what is type of reaction is going to take place there? If we have concentrated sodium hydroxide and there is no water, then we are going to have an elimination reaction. So that's the reaction that is going to take place. So if it is an elimination of haloalkanes, we also call it dehydrohalogenation, and we also call it, to be more specific on this one, it's supposed to be hydrochlorination. So now, how does this reaction really take place? So just writing the dehydrohalogenation. To be more specific and say dehydrochlorination is not that much important, but you need to know the dehydrohalogenation because sometimes they will ask you what type of elimination reaction it is, and so you need to know. So now on the reaction, the first thing that is going to happen, we have a beta leaving group, which is our chloride or ion or chlorine atom. So it is going to leave. And then after being eliminated, between the carbon atoms attached to our carbocation, which is carbon atom number 2, one of them must lose a hydrogen. So that one of the carbon atoms must form a double bond with the second carbon atom. So which one then is going to lose the hydrogen between the two? According to the verse, in general, the most substituted carbon atom is the one which is most likely to lose another hydrogen atom. So the most substituted carbon atom there is carbon atom number 3. So in other words, we usually say the poor gets poorer. So why is it losing that hydrogen atom? So that it can form a double bond with carbon atom number 2, which has already lost a chlorine. Right, so the Cl group, which has been eliminated, will be attached to the Na atom, and then the hydrogen atom will be attached to the OH atom, OH group, from sodium hydroxide, forming the major product, which is going to have a double bonded carbon atom number 2. Not me confuse you, the hydrogen will be at the bottom, but for now it doesn't matter context, but the most stable one will have hydrogen atom at the bottom and the one at the top, but it's fine. And then that will be our major organic product, and then we're going to have 2 inorganic products, sodium chloride, and then finally we have water. Now usually they ask you to draw using structural formula, so this is what you'll be expected, especially for water. You need to draw water in its structure. So the organic compound produced there, it has a double bonded carbon atom number 2, that's number 1, and then it has 4 carbon atoms. So for that reason, the name of that organic compound formed is but2-ene, which is our major product in this regard. And then obviously our minor product will be having a double bond between carbon atom number 1 and 2, but our focus is on the major product. So which one corresponds to what we just got from that? So the first one, A, will be a product of a minor, the one that doesn't follow the diverse rule. And then the second one, so the first one is minor, and then the second one, B, that will be our correct answer in this regard, which is but2-ene, which corresponds to our analysis over there. And then butane 1-ol will be a product of the addition reaction, which might take place in a minor product. And then finally the 1.7, which one of the following compounds is an aldehyde? So we're just looking at the names of these compounds. So the Al, the suffix, then tells us that's an aldehyde automatically from the name. The second one, B, pentan 2-ol, the Ol suffix then tells us it's an alcohol. And then C, pentan 2-on, then that's a ketone right there. And then finally The OAT is usually found in ketones at this level, which is grade 12. So, I mean ester, sorry, not ketones. My apologies for that. So, it's an ester. And then, so the correct answer in this regard is A. And then we move on and consider this supposed to be 1.8. And then the other one at the bottom 1.9. But then the statement is consider the reaction represented below by the equation. So we have the first compound which is reacting, it is an unsaturated hydrocarbon, which is of course in this case an alkene. It's reacting with hydrogen to produce a saturated hydrocarbon as well, which in this case is an alkene. Right, so now let's just discuss. Now we have different types of reactions, as we can clearly see. So if we are moving from saturated to saturated, there's going to be a certain reaction. And then if we're also moving from saturated to unsaturated, which is a certain reaction. And then we also have a movement, like in this case, from unsaturated to saturated. There is also a certain type of reaction that takes place. So saturated to saturated, that's substitution. And then saturated to unsaturated, that's an elimination reaction. And then finally, unsaturated to saturated, that's addition reaction. So you should know this type of reaction. So obviously, now then it clicks in your mind, oh, so then it means this reaction is an addition reaction because we're moving from unsaturated to saturated. But then we have different types of addition reactions, and we normally know that at this stage, the addition reaction that we talk about, it is that of alkenes. They form sometimes alkanes, like in this case, sometimes they form haloalkanes, sometimes they form alcohols, right? So now all of that, then it depends on what has been added. It determines the final product that we are going to have at the end of the reaction. Option A, hydration. That's the addition of water. And we know when you hydrate. And then B, dehydration. When we then it means we are removing. So that to be the removal or elimination of water. And then C, it is just a substitution reaction. That's when we remove and then we replace with something else. And then finally we have D, which is hydrogenation. Hydrogenation, it is the addition of hydrogen, which in this case is what is happening in this reaction. We can clearly see there is an addition of an H2 group, H2 molecule, sorry, which brings about our final product, which is an alkene. So the correct answer will be D. All right, moving on to 1.9. So now it says consider the structural formulae of compound below. So there's the compound that we have. We can clearly see from the functional group that, oh, this is an ester, right? So now the question is, which one of the following pairs of reactants can be used to prepare the compound in the laboratory? So an ester, we know it is a product of esterification when we have a primary alcohol reacting with an carboxylic acid. So the first part, which is the O attached to it, then it is coming from an alcohol. And then the second part with the carbonyl group attached to it, then we know that's the carboxylic acid part of the molecule. So then the alcohol part, how many carbon atoms does it have? It is 3 carbon atoms. Therefore, it means it is coming from a primary alcohol, which is propan 1-ol, and then the acid part, which is the carbonyl group attached to it. It has 2 carbon atoms, obviously, which is coming from ethanoic acid. So let's see which one will be the best combination. So be very careful then. It doesn't necessarily mean that all the times the first part of the compound is the alcohol and then the second part is the carboxylic acid. See the one that contains the carbonyl group, then that's the carboxylic acid part, and then the one that contains the oxygen only, which is the what you call this, a substituent, a branch, so to speak. That's your alcohol. And then obviously from the options you can clearly see if A and B are automatically out, and then we consider C, that will be our correct answer. D is automatically out because of its combination of organic compounds that it has. So we go for D as our correct answer.